Okay, in this concept we're going to talk about tangency in circles. A tangent line is a line that intersects the circle in exactly one point. So it looks something like this, right? So if you have a circle, and if you had a line that would intersect the circle at a single point, this line is called a tangent to circle P, right? And the point of intersection is called the point of tangency. Now you may think that, or let me rephrase this, it may visually appear that the line is intersecting the circle at more than one point, right? So we're assuming there's an intersection here, but visually it seems like there are more intersections here, 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 etc. And then the same on the other side also, okay? Well, visually it may seem this way, but theoretically and geometrically it is not. A proper tangent only has a single point of intersection. So if we zoomed in, right, if we zoomed in on this, right, actually let me draw this a little bit better. Well, yeah, this is not really a circle. There we go. Something close. So, right, if we drew the line, if we zoomed in, right, geometrically there should be just a single point of intersection. But here visually it seems like there are more points of intersection, again, because just because of the way the line is drawn. Okay, it's not that easy to draw a tangent showing only one point. Remember, a single point is essentially an infinitesimally small position in space. A point does refer just to position in space. So it's not really easy to draw a point per se. Okay, but again, the tangent line is a very important abstraction. Okay, and do keep in mind that the intersection is only at one point of the circle. Now, a tangent line is perpendicular to a radius of the circle at the point of tangency. Okay, so this is another very important property of a tangent line, a very important defining property. So if you draw a radius from the center of the circle to the point of tangency, this radius has to make a right angle with the tangent to the circle at that point of tangency. Okay, so we say tangent line L is perpendicular to radius AP at point P. At point A, sorry. Okay, perpendicular at point A. Okay, let's look at an example. Line L is tangent to circle P at point A. So this is line L, circle P, point A. Okay, so we need to find the value of x, which is this angle in the triangle. Well, we're only given the central angle, but again, since L is a tangent, right, then our point of intersection with the radius has to be a right angle between the radius and the tangent. Okay, so we know that this is 90 degrees, right? So we have 180. So obviously the total sum of internal angles of a triangle is 180. So 180 minus 90 minus 55 gives us x. Okay, so solving this we get x equals 35 degrees. Okay, another very important property of tangent lines is that if you had two segments that are tangent to a circle while at the same time sharing a common endpoint outside the circle, just like this configuration, right? So we have this tangent at this point, and we have this segment tangent to the circle at this point, point B, and both of these tangents happen to intersect at some point, then these two segments between the common point of intersection of both segments and the tangent point, or the tangency point of both segments with the circle, both of these segments have to be congruent. Okay. Again, you can logically test this and see why this should be the case only when these two lines are tangent. Let's say we take a point, whatever, here, right? If I take a point here, well, actually, let's make it a little off, right? So if I take a point here, or even here, right, just a little bit off, and I draw a line this way, well, look at that. Well, actually, it's not a very nicely drawn line, but I just want to prove the point to you. So if I come in here, you see this is not a tangent anymore. It doesn't intersect the circle at one point. This crosses like a chord, and we'll discuss this in an upcoming concept. However, again, this is not a tangent anymore. Okay, so this is not a tangent, and obviously, if I connect to this point also, I get the same effect, right? Again, my line is not perfectly drawn, but obviously, again, this is not going to be a tangent. It's going to intersect the circle at more than one point. Okay, so again, if you start from a tangent, right? If you start from any tangent, I mean, you could have started, again, you could have started from this guy and this guy, right? And if you draw the right tangent through this point, right? And the right tangent through this point, again, this would be the point for this guy and this guy. Okay? So do keep this in mind. If you start off with a tangent, with two tangents, actual tangents from the circle, and they intersect at some point, the segments have to be congruent. Okay? So in the figure above, AB and AC are tangent segments and meet at point A. That means segment AB is congruent to segment AC. Let's look at another example. So we have this circle, and we have circle P, and we have a common point outside where both segments, tangent segments, come into intersection. And then we have the points of tangency for each segment. Okay, we have this angle 35 degrees, and we have a missing x. So keep in mind, this is a tangent, but don't assume that this angle is 90 degrees. Okay, it's not. Why not? Because, well, this is not a radius. BC is not a radius. If I had this, PB, this would have been 90 degrees. Okay, but I don't have this. I have this line, or this segment. Okay, so segments AB and AC are tangent to circle P. What is the measure of x? So again, assuming these two are congruent based on what we just mentioned, right? That two tangents meeting at an external point will essentially have equal segments. So if this is congruent, then whatever is remaining is, so these two angles are congruent also. Okay, so 180 minus 35. So obviously we have three angles in the triangle, and 180 minus 35 is 155 degrees. So these two angles both add up, are equal, and they add up to 155 degrees, right? Sorry, this should be 145 degrees. Okay, so both of these angles add up to 145 degrees, and they're equal. So the sum of x is just 145 divided by 2, which is 72.5 degrees. Okay, x equals 72.5 degrees. All right. And here we have our exercises. Please pause the video, work on these, and come back for the solution. Okay. In the figure below, find the value of x. So x is the radius, this one and this one, okay? 16 is this segment. Okay, 16 is not this entire thing. That's not 16. Okay, 16 is just this part. Okay, or I could have just, done it the other way. Okay. Looking at the triangle, though, and again, since this is a tangent, right, and with this being a radius, well, we can assume that this is 90 degrees. Okay, if this is 90 degrees, then this is a right angle triangle. which has c squared equals a squared plus b squared, right? Well, what is c squared? C squared is, well, c is 16 plus x, right? Or you could say x plus 16, right? This is c. So c is the hypotenuse of the triangle, okay? C. And then, you know, a or b, whatever, whichever way. But this is definitely c, which is x plus 16, all squared, is equal to a squared. Let's call it, you know, let's use 24 squared. Or actually, let's use x first. So x squared, which is this. And then 24, let's make that b. So plus 24 squared. Okay. This looks intimidating, but it's not, I promise. Whenever you see something like this in geometry or anywhere in algebra, just do not get intimidated, okay? Just start expanding this. So x squared plus x times 16 times 2, which is 32x, plus 16 squared, which is 256, equals x squared plus 24 squared, okay? Or I could have said, you know, minus x squared minus 24 squared is 576 equals 0. Okay, I basically brought both of these to this side, okay, by subtracting x squared and subtracting 24 squared. So x squared minus x squared goes away. 32x equals 256 minus 576 is minus 320, right? Actually, I can bring this on the other side also because I'm solving for x. So 32x equals plus 320. So x equals 320 divided by 32, which is 10. Okay? So this part is 10, so the whole leg C is equal to 26, and A is equal to 10. Okay? Next exercise. In the figure below, find the value of x. So we have this circle. We have this as a tangent. This is 41 degrees. With this being a tangent, so the angle is 90 degrees. So x is essentially what's left out of 180, right? So 180 minus 90 minus 41 is equal to x, because it's whatever is remaining out of the triangle internal angles, you know, after you take them, you subtract the angles from 180. So 180 minus 90 is 90 minus 41 is, so x is equal to 49 degrees. Okay, and this is it for this concept. See you in the next video.